Everyone to Ethereum enthusiasts, New York City. We have a great guest tonight, but first I'm going to invite Thoughtworks up. This is our first time at Thoughtworks. This is a great venue. I want to really give them a round of applause for hosting us. Come up and take a minute and tell us about yourself.
Hi everyone, I'm Lauren. This is Justin.
I'm Philip.
Sorry, I was taking for you.
That's all good. So we're Thoughtworks. We are a global software consultancy, and we build custom software for our clients, solving their business problems with strategic solutions. So,
Agile.
Yes. How many offices do we have?
We have 38.
Yeah. And
About 38.
yeah, and
Around the world: India, China, Latin America, Australia, Europe.
yeah.
We're based in the head office in Chicago.
Yep. And as of late, we've done a few different cryptocurrency small projects. Lauren and I were actually on one of them, so we can talk about that more afterwards if you'd like.
Good.
All right. I won't take up too much more time. Alexei, I'll let you kind of quickly introduce yourself. I met you in Shanghai. You're one of the first non-consensus customers of my project in Fiat, so you're welcome. You're always a deep spot in my heart. Anyways, Alexei, go ahead.
Great. Thanks. So today we're going to be talking about a key piece of the decentralized stack that enables smart contracts to kind of take things to the next level so they can be competitive with existing financial instruments in securities, insurance, whatever financial instrument you'd like. That key piece of the decentralized stack, which our company focuses on, is something called an oracle. So an oracle is basically middleware. It sits between a smart contract network and external APIs, data sources, and payment systems. Because inherently, smart contract networks are unable to talk to these systems. So by virtue of certain security requirements and just how consensus works in these networks, they are unable and will be unable to talk directly to data feeds that they need to know about outside the network. And they are unable, and probably will remain unable, to talk to off-chain payments, such as bank accounts. And these two features of high-quality data in and widely accepted payments out are things that our company is focused on solving for smart contract developers so they can build something that meets a kind of higher standard and is able to compete with non-smart contracts. So the first thing to think about, I think, from the perspective of why this is useful, is kind of a thesis on what smart contracts are competing against and how the world looks today. So today, what you have is you have financial institutions, banks, insurance companies, remittances companies, basically financial services companies that have the ability to make financial products, whether it's a security or insurance or remittance product for consumers, whatever it is. And they have the ability to do this because they can manage the complexity related to it, basically. And that complexity, when you really look at it, lives in something called the bank middle office. And the bank middle office is basically just another word for people that deal with contracts all day long. They deal with figuring out the logistics of executing, finalizing, agreeing upon, completing, whatever you want to call it, the contracts that are related to a particular financial product. Security, insurance, remittance, whatever. They can also be regulatorily, they can comply with regulations in ways that fintechs can't. They can access high-cost data providers. And they can access high-cost payments providers that are kind of built as mission-critical systems that they pay a lot of money for, that other people can't either get into or afford or use. And this all goes to making their kind of contracts, financial products better, right? So at the end of the day, this is what a smart contract will be competing against. In the current world, how this looks is fintechs exist. And fintechs mainly service banks. Or they work through banks. They have access to bank APIs. They use various bank capabilities in terms of collateral management. Many of them just service banks, because that's really the role that the fintech has. The fintech doesn't have the capacity to comply with regulations. It doesn't have the capacity to issue and service the huge amount of redundancy you need to create certain financial products. So in this example, you have all these different contracts in many departments, and banks always say, woe is us, we have to have all this redundancy, it costs so much, it's such a problem. But that's part of what's insulating them from competition, right? If everybody could just make financial products, then everybody would, but everybody can't. And this, as far as we can tell from looking at this and working with banks, is one of the reasons, is one of the main reasons, is that they can make better financial products due to being able to manage this complexity around all these contracts. Now, the world we're all hoping to move towards, or at least we're hoping to move towards, or we're excited about moving towards, is a world where it basically becomes easier for fintechs, decentralized applications, crypto startups, DAOs, whatever you want to call them. Basically a smaller group of people doing something with financial instruments. Once again, securities, insurance, remittances, whatever, take your pick of what you'd like. It's all related to financial services to one or another category of people. And for them to be on, I guess you would say, maybe not on exactly an even footing, but on a more even footing. So that a bank, an institution, somebody that is used to dealing with high quality contracts looks at what the fintech, DApp, DAO, crypto startup, whatever the name is, whatever that smaller entity provides, has a high level of quality. It is competitive. It is not something that doesn't meet the standards of, I want to get paid this way, I want it to be based on these reliable triggers. There's all these kind of systems that these folks are used to using. And people in finance and in the institutional world where there's, I think the numbers are now quadrillions amounts of dollars, right? That's where the volume is. That's where smart contracts want to compete, as well as consumer applications, but that's also definitely where. So the goal here is really that all the complexity of these many contracts goes into this one contract. It's written from the beginning. It's able to acquire its own data, so you don't need a whole department to give it data. It's able to automatically make payments, so you don't need a whole department to make payments happen. Regulators can look at it directly, so you don't need a whole compliance department to talk to your regulator. That's 3 departments. That's a lot of people, and that's the difference. So that's kind of the thesis of why this is important, is you want to eliminate this complexity so that basically maybe we're in a world one day where fintechs, crypto startups, DAOs, dApps, whatever you call them, can go, I made my contract and I sent it to my regulator. My regulator looked at it and I didn't need a compliance department. Or I wrote it into my contract and it paid on its own. And I didn't need to hire a 50-person collateral management department. And so that function within a small group of innovative people doing something cool and different can now exist, right? That can exist. Now, what is the hurdle to that world kind of appearing? Because we've been trying to make that world appear for a while. We've been working on smart contracts for, at this point, over 3.5 years, basically when some of the first ones came out, and we've hit a lot of hurdles. And the 2 hurdles that we've consistently hit, and the ones that we've kind of turned our infrastructure towards solving internally, and now we've exposed externally, because there's a lot of developers interested in solving these problems for their applications, which has kind of changed the focus of our company from making the contracts for banks and insurance companies to providing this better set of infrastructure that other developers can use. The 2 real problems are connectivity, right? If you want to make a contract competitive with today's contracts, and today's contracts have high quality data inputs, and you make a contract that doesn't have high quality data inputs, on that dimension it starts to fail. If you're competing against a contract that pays in dollars because people want to receive dollars, and your contract doesn't pay in dollars, 5 years down the line, 10 years down the line, sure, everybody might want to get cryptocurrency, and that's great, and I want that to happen, and I've been waiting for that date for a while now, probably longer than most people. And but until then, right, we're not going to wrap up shop and go home. We still got to build something. We still got to move something forward. So the way we probably move that forward is some level of interoperability between the cool features of this and the legacy systems that people want to use for data inputs and payment outputs. So that first problem is connectivity. The second problem is privacy. So the analogy I always remember for this, and some smart folks I know seem to use it sometimes also, so I think it's not bad, is that HTTP versus HTTPS, right? So you had HTTP, and you had academic institutions sending around public information, and it was great. Great mechanism for doing that. It worked really well at the time, and great. But once you have HTTPS, you have people sending private messages, and you have email, right? The first killer thing. And then after that, you have e-commerce, right? It's not that people are super paranoid. It's that for certain kind of operations between two people that don't know each other, you need some amount of privacy from some third weird man in the middle guy who is going to do weird stuff. So I think kind of same scenario here, right? For a lot of the contracts that I'm familiar with in financial services, insurance, remittances, you're going to need privacy. From a comfort perspective, people want privacy for those financial contracts, and B, sometimes from a legal perspective. So you just need privacy. And so that's another dimension that smart contracts need to kind of like check the box and go, yep, we're good or better. So those are the two main hurdles: the connectivity to the right inputs and outputs, and the privacy. So our solution to this, with one addition of our product next to everything in the graph, is basically, or really our product or any other Oracle. This is really just kind of, we're just laying out a thesis at this point in this conversation. So the thinking is that you need fintechs, DApps, DAOs, crypto startups. I know I keep saying that. I just don't want to. There's like 6 definitions for everything in this space, so I don't want to upset anybody. So I'm just going to do that sometimes. Sorry in advance. So they would have an Oracle. Data providers would have an Oracle. And so the origin is where the infrastructure to provide the data runs. Payments providers would have an Oracle. And just to make clear what an Oracle is basically something a smart contract can talk to. Or the Oracle can talk to the contract. The Oracle can ask it things and do things based on how it's written. So basically, the connectivity question here gets really quickly solved. You're a data provider, you have APIs, you like selling API credits, you keep hearing about blockchains, you don't know how you fit in. Maybe you can offer your services to smart contract developers. How do you do that? Guess what? There's an easy way to do that. It's called an Oracle. We have something called the Oracle Kit. We offer it to data providers, payments providers, folks that basically want to offer their services to smart contract developers. And that is, I would say at this point, the main focus of our company, is getting those high quality data providers, payments providers, e-signature providers to be able to offer a high quality source of data payments, some service that developers want, to those developers. And so everybody wins. Data providers, payments providers get more usage and get, I would say, cool usage, because smart contracts are cool, everybody knows that. And then also the developers greatly benefit because they don't have to call up whoever and go, hey, I have a smart contract, can you let me use your system? Developers don't want to do that, right? Developers just want to like build their use case, connect it up to what they need to connect it up to, get it to work, hook some libraries together maybe, and just keep going, right? That's what it seems people want to do over the past 40 years since we stopped working on like nuclear physics or whatever, but that's a whole other thing. The privacy issue is also slightly mitigated. So the privacy issue is mitigated based on off-chain computation. So the Oracle can provide proofs about the computations it's done. So if you want, you can share a off-chain computation with people involved in the smart contract. You don't publish it to the contract, so it's not public. Because just in case anybody doesn't know exactly what problem I'm talking about, the problem is smart contract networks can't process encrypted values. Well, except like Zcash and some really cool cutting edge things with some simpler operations. But long story short, you can obfuscate the data, you can kind of mask it, which will make the contract really confusing, but it won't keep it private. So basically, pretty much the only option we see right now for reliable privacy, if you can't compute encrypted values, is off-chain computation, and then some kind of proof from the off-chain computation appliance that it has done the off-chain computation as needed, right? So that's kind of a midway solution. Really, I think in all likelihood what's going to happen with that is that's going to get solved on the protocol level, on the network level, and soon enough you will have either zero knowledge proofs or homomorphic encryption, allowing kind of on-chain computation of encrypted values. So that's not super duper the problem we're focused on. We kind of have like a partial stopgap solution to it, I would say. That if you have a use case where you're really worried about privacy, like it's like a hard and fast thing that you need to provide, you can provide it. It won't be perfect, but you can provide it better than just publishing stuff to the chain and hoping people don't figure out that you multiplied something by 2. And that's how you got it in there. That's how you obfuscate it. So this is really the proposal we have and the technology we've built. We have an Oracle service where you can quickly go and make an Oracle by providing an API, and then it takes any API and turns it into an Oracle that your smart contract can use. The average time right now to do that is between 11 and 12 minutes. That we just offer that for people to get started. We're not super fans of that model. We are really fans of a more decentralized model where data providers, payments providers run their own Oracle. So we don't want to end up becoming an Oracle service that all the contracts talk to, because that creates a centralized point of failure, right? If there's an aggregate, increasingly larger aggregate value talking to a single Oracle service, that thing becomes a huge honeypot, right? And the more successful it becomes, the more the model propagates, the more contracts tie themselves to that Oracle service. And that just doesn't seem to be the way our space wants to work. And from a security perspective, it doesn't seem so wise either. It seems much wiser to just give the data providers, the payments providers, the ability to offer smart contracts, connectivity to their services. So a quick example of how we... So a quick example of how we do that, or how we've started to do that with some folks, is one of the companies we've started working with is Swift. So Swift is a very large, basically payment standard, the largest payments messaging standard on the planet. At this point, I think it's 11,000 plus banks. And we're working with them and thinking through, in addition to other people, data providers and e-signature providers, but just in this example, Swift, how do we get a smart contract to send a payment over this huge network that will basically give smart contracts access to pretty much all the bank accounts. Pretty much all, a lot of them. 90% plus, I would say. And how does that work? How do we solve that problem? And like, how do we get that out to people? So just to walk through the example, and you guys might start getting a picture of what I mean by a kind of a better smart contract security or a better smart contract product. So in this example, we really have 2 contracts. The first contract we have is a market rate contract. The market rate contract basically aggregates data from multiple individual sources. So in this case, it's an interest rate. So it takes an interest rate from bank 1, bank 2, bank 3, 4, 5, 10, 50, 100. It takes the interest rate from the banks. And then it combines those interest rates into a market rate, kind of a shared average rate that banks commonly use in their securities. Now this is something that banks, believe it or not, pay about $10 or $20 million per bank to do. They literally pay $10 or $20 million to individually give their data to a company, for that company to average that data, perform that very complex averaging calculation, and then return the result to them for $10 or $20 million. And if you want to get that market rate and you're a startup, like I said in my previous thing, it won't be $10 or $20 million, but it won't be nothing, because they can't give it to you for nothing and give it to them for $10 or $20 million, because one of them is going to dress up cheap and show up and say I'm a startup, right? That just can't happen. So, simple example there. So we're able to get the banks putting in their data, we're able to get the data to the contract, and we have this simple operation on the chain, and it creates, in this case, something close to a public good that all the participants benefit from. And the kind of the impetus for that was we made it easy for them to get their data to the contract, right? So, simple example of how simplifying the problem of I just like want to get my data to a contract. Really simple example in terms of something people take $10 or $20 million for per year each got simplified away, right? And became accessible to fintechs, right? So that's one example. Next example is, okay, we have a market rate, so we have the rate that a security would use. This would be the rate it would use to calculate its payment, the amount of money that it needs to pay to whoever. In this case, we just did a bond, because bonds are dead simple. Just drop dead simple. So we did a bond where it took this rate and it calculated a payment. And this is the second step where now we're looking at, okay, you have a smart bond or a smart contract security. How do you get it to pay? Something that like the guy in Malaysia wants. He has a bank account in Malaysia. He bought the bond. He wants his money in his local currency. Likewise for the guy in India. Likewise for the guy here. Likewise for most people, unless they're really into crypto. And that's all going to change. I'm not saying that that's not going to change. That's totally going to change. Definitely. Definitely. 10 years. 5 years maybe. But that's still 5 years away. Right? And I'm impatient, so we got to like, there has to be a stop. And probably it's less likely unless like the contracts today start doing something valuable. Right? So the sooner smart contracts start doing something valuable and become like genuinely highly competitive with high quality existing financial services contracts, the sooner adoption happens. It's all kind of like a cycle, right? I don't have like a cycle slide, but you can imagine a set of arrows going together. So that's gonna, it kind of feeds that. So in this example, it's very simple. Smart bond calculates the payment using the other contract's rate, and then sends a payment transaction through the network. It sends the payment transaction to an on-chain contract. The on-chain contract is the Oracle's contract. That Oracle's contract is there to receive payment instructions, right? So I'm somebody who either executes these payment instructions as a payments provider, or I'm a bank who wants to execute that payment instruction through my system. There's an on-chain contract that has my name on it, and I tell people, hey, when you make a smart contract security and you want me to pay or you want my payments provider to pay, you send an on-chain transaction to this contract, and then something will happen if it's supposed to. So the on-chain part receives that. The off-chain part basically looks at the on-chain part and says, what should I be doing? It can compare against whitelists. It can error check. It can do a whole bunch of stuff. Well, it does do a whole bunch of stuff, depending on how much you want it to do. Then the off-chain part, based on what happened on-chain, executes the payment in this case for Swift in XML, or whatever format you want, really. We don't care. We have a flexible system where anybody can show up and they can build something called an adapter. So the adapter is basically integration-specific code, and the core of our Smart Oracle is just core features around scheduling, credential management, generating APIs from certain contracts, all kinds of different features that you would want from an Oracle. So then the payment network does whatever it needs to do, and then it says, okay, I'm done. I paid Joe. And then basically there's some kind of data off-chain, right? There's data about an event off-chain. That's important. Joe got paid. Now, what we don't want to do, what makes no sense to me, I don't think anybody's ever said it makes sense, so I'm saying that, but we don't want to do this next thing where we kind of keep the data in different places. So we don't want the data about the off-chain event to go ahead and stay in some off-chain system, and then leave whatever on-chain stuff we have in the on-chain system, and then we're back to having 50 systems, and we're back to this graph, right? Instead of this graph. We want to be at this graph, where all the data a regulator would need, anybody would need, a risk analysis company would need, everybody would need is just pop right into this contract. It becomes a single complete record, and that means getting confirmation about off-chain events back into the contract, right? We want the contract to be the definitive record of what is happening with this financial product. So, okay, this is that other arrow going back. So then the Swift network will return confirmation data, and that is put back into the contract. So now the contract is done. It says, okay, I paid, I got a confirmation back, I'm complete. I have everything I need to prove that A, I said to pay, and B, payment happened off chain somewhere. Here's the proof. And so now, if I'm a fintech or even a bank or a regulator or whoever, I don't need to go to two places to figure out what happened with this financial product. I don't need to call the bank that made it. I don't need to call a data company. I don't need to pay them. I don't need to do any of this. I just need to look at the contract, and I'll know what happened. So this is kind of a best practice that we advocate very strongly, and we've built a lot of stuff around to make it so that you can keep the contract as like a complete record. We have a few cool things on this, like how to make it show certain off-chain data and a synopsis of what's in there. Long story short, if you're interested in that, we can do that offline. So yeah, I mean, as you can see from this, the focus for us is on being able to enable individual companies, whether they're banks or fintechs, to interact with a contract on chain. And B, the larger goal, the thing we're really focused on, is getting high quality data providers, high quality payments providers to offer their own Oracle. That's just the logical, more decentralized, more secure, right? You're gonna want people signing data at the origin. Once you get to contracts having a certain amount of money, like that's just the logical path that we pretty much feel very strongly about. So right now, I'm just going to walk through the four main things that an Oracle, smart Oracle, can do for you, can do for a smart contract developer. So the first thing that it does is basically gets data in. This means talking to APIs that return JSON, talking to APIs that return XML, SOAP, REST, whatever. Basically, there's different adapters. There's data provider specific adapters for whatever weird thing they might have. And then that data coming in through that adapter, through that lightweight integration code, touches the core features around scheduling, things like credential management, and then that uses other adapters. So adapters for example, let's write into Ethereum. Basically, the focus of the whole data in piece of the product is to make it very easy to show up with an API. We personally prefer JSON. Show up with an API and turn it into a feed for your smart contract very quickly. We have two ways to do that. One way is on the site. You can go on the site, and as I said, through basically a web-based interface, you can drop in the API URL and generate an Oracle relatively quickly. The other option is you actually run the Oracle yourself, which we absolutely encourage you to do, or we can host it for you to get you started and have that type of relationship where it's a new thing for you and you need somebody to host it and you want to get used to the APIs and stuff like that. And then the real focus of that is kind of whatever we host for you will not be some weird API infrastructure we came up with that you are then forever tied to at the hip. It will be like the APIs of a piece of software that you can run that's open source. And that if you give, let's say you make a cool smart contract and then it's for a bank and you want to sell it to the bank, you don't have to show up and go, I made a great smart contract, but for it to work you have to use this service because it's super tied into my code. You can kind of just go, here's my smart contract, here's my Oracle setup, here's my product, time to pay me. And we're just excited about that. Basically, letting people be able to do that rather than have to figure out this Oracle problem. Like, people don't want to figure it out. Nobody really wants to figure out stuff they don't care about. There's 50 things I find interesting, but there's like things I really care about. And for most developers, they're just myopically focused on whatever use case they think is fantastic. And whether it is or isn't doesn't matter. Like, that's all they want to do. And the history of good like MVPs or good products that came out quickly and did something good isn't that those developers sat there and were forced to build 50% of the infrastructure they use, right? Usually it's like, yeah, we knocked out an MVP, we put these 5 libraries together, used this service, and we tried it out and it worked, and now we go to the next stage, right? And if it doesn't work, then I can do that again next week because I can do it quick, right? I don't have to build a whole new piece of infrastructure. So data in is the most fundamental thing, because if you don't have data in, all you're really going to be able to do with the contract is send it a signature from a wallet. And you're going to sign on a multi-signature and something's going to happen, and you'll know that multi-signature works, which was cool 2 years ago, but today I don't know how far that's going to go. So getting data in, probably important. And running it yourself is totally an option. Yeah, people very, very much differ on that, actually. Some people don't want to take the risk of running an Oracle. Some people do want to take that responsibility on. It really just varies between use cases. It's very use case specific. Yeah.
What kinds of risks are involved?
Well,
Oracle gets hacked and returns bad data?
we're going to get to that in 4 slides. But yeah, basically you have to secure the Oracle. You have to secure its private keys. So if we host it for you, at least initially, to prove out whatever MVP you have, it makes things a little bit simpler. Some people want to control the Oracle maybe because they have proprietary data that they need to put in, and they don't want to send it somewhere else. Some of the time when people don't want to run an Oracle is when there's legal issues. When they, for example, don't want to be the signer of a specific transaction, they want somebody else for like minutia legal weird reasons to be like they signed last, to be able to just go like they did it, even though they paid them to do it, or it's really weird. But it's very use case specific. Okay.
Could you make the analogy that it's similar to whether you're going to, a website, like you're either going to host it yourself or pay somebody to host that and manage everything that goes along with it, including security, etc.?
I mean, that's an interesting question. I've never really thought about it that way. I don't know if that's a great analogy. Maybe it is, but the thing that I've noticed in a lot of the current setups that we're looking at is that the setup doesn't work if you don't have an Oracle. So people are either forced to build it themselves, or they can use this or something else, right? So maybe if you think back to when people had to host their own website, like on their computer, maybe, I don't know. That's an interesting point. I'll think about it. Thank you. Sorry I didn't have a better answer. Yeah, bro.
How do people know that the source are the...
I will get to that 4 slides. All future questions of that type are 4 slides away.
Question. When you mentioned earlier the example with the LIBOR computing average, is that done in a homomorphic way?
No.
Because then what's the, I believe that's truly the value add, right? Because ultimately, if somebody's going to see LIBOR before everybody else, there's a risk in that.
Yeah, you're right. It's a bit of a weird example. It has that privacy issue. Basically, that suffers from that privacy problem, that we can't keep the individual bank rates private. What we could do, to answer your question, what could happen is there could be an Oracle network that computes the LIBOR rate, or there could be the single Oracle that people feed their individual LIBOR rates into. You could have a setup like that, but that is not that much better than what exists today. Yeah, that's a nuanced point. Basically, the market rate smart contract becomes cool when you have on-chain privacy for computations. So that's a good point. Yep.
Have you succeeded in actually getting any well-known interest rates up there as a public good yet?
Yeah.
Which ones?
So we made a number of public oracles that put up the Ethereum price, that put up the federal funds rate, that put up the Bitcoin price, and I will actually be able to quickly show you how you can make one of your own and make it a private or public good. But yeah, we've done that. We've been doing that for a while.
Okay. So Fed funds is one.
Yeah, Fed funds is the one that like people from crypto land don't care about.
Not LIBOR yet.
Not LIBOR. Well, yeah, we can put LIBOR in there, just nobody's asked for that yet. We can put it in. We can get, you can get almost any data with a huge delay. It's just useless. There's a certain delay.
What if you're compelled to lie? What if you're compelled to make your oracles lie? you're going to go to jail unless you fake the price right now.
I'm going to go to jail unless I fake the price right now.
That's the scenario. What happens if that in that case?
For
Is
some
the
reason,
whole economy dead?
I'm sorry, you're saying, I didn't hear the question.
So what if you're compelled by
To,
violence to fake that data? You control the oracle.
I heard before you work in info security, so I get where you're coming from. If we're at, so right now that isn't a huge risk, so that isn't something, it isn't. Not for the numbers rolling around yet. For the numbers rolling around soon, when that is a risk, basically, I'll give you a preview of what's 4 slides away because that's the everybody wants to know.
Sorry.
Is basically HSM-based attestation.
Okay.
And the best thing right now on the horizon closest is SGX, and we're working with a number of folks on that. And basically that would be it. Well, actually, the world we want to get to is we have this HSM setup, and we have it in the data providers and the payments providers, and they have it in their infrastructure. So whatever systems they have to minimize that risk already act on that same piece of kind of infrastructure that talks to smart contracts. And if you're really worried about that, like if it is some contract from one of these like Wall Street movies where the world is going under and banks are getting dissolved and like people are defaulting, then you would probably just create a lot of redundancy. That is most likely how you would mitigate that risk. But at the point where that becomes a realistic risk, I don't think some Oracle service should be running it. There should not be a startup Oracle service running it. There should be like the people that already mitigate that risk running it within their own infrastructure, using whatever voodoo they use to do that. Is that?
Yeah.
Okay, so that's external data sources. That's kind of just one of the 4 key values here. The second key value is off-chain payments in fiat currency. So this is something we've worked with and struggled with for like, of the 3.5 years, probably 3 years. The first 6 months we were just like, what's going on? So basically from the start is people would come to us and go like, I heard about this smart contract thing, it's so cool. Can you pay me in dollars? And we're like, maybe in 20 years, so that's not how it works. And that it was never the right answer, and it probably won't be the right answer for another couple of years. So the answer here is the credential management that the Smart Oracle has, and the scheduling, and the capabilities it has to interact with data APIs are basically applied to basic APIs of payments providers. The better version of this is, once again, the payments providers run it within their own infrastructure as a service, just like they run APIs. Now they run in Oracle, just like they have API documentation page, they have an Oracle documentation page, and that's it. So Swift, we're working with them, a few banks, and a few other folks that I can't announce quite yet, and we're really trying to see if we can like solve this problem soon, because there are a lot of use cases that if tomorrow they could create an on-chain record that is like reliable and easily viewable, and that on-chain record could securely, reliably pay somebody in their bank account, like, that is a big thing. We think that's a big thing. That's a big thing. I'm pretty solid on that. I'm glad to say that. Yeah.
Does that have to be real time, or can that be typical settlement? Doesn't matter.
Can be whatever it's going to be whatever people are used to. Nobody's going to go like, you're going to send me a Swift payment, but you're using a smart contract, so it's going to happen in a second. They'll just be most people won't even know it's a smart contract. Like some of the better use cases I've seen for smart contracts are just like, we create auditability and it solves some internal headache for us, or we optimize some process and we can prove something to somebody down the line. And a lot of the users, they just don't know. Some people know. Like there's these 2 kind of parallel worlds. There's kind of like crypto startup land, where people are showing up and saying, I have a smart contract asset, and so it's bulletproof in 16 ways. And it's bulletproof in like 10 ways. It is. But are those the 10 ways you care about? Maybe they are, maybe they aren't. Like, so that's like still up in the air for most people. But I have views on that. We can always So off-chain payments is either talking to the API infrastructure of the payments provider, or what we want to get to, Oracle page for payment provider X. That would be so cool. So the next piece, the third kind of valuable thing that folks will be getting from Oracles is the ability to use other chains, to use them for whatever they are meant to be used for. So if you have a Hyperledger chain that has a bunch of data that you care about for whatever reason, great. Ethereum's just not going to talk to it out of the box, most likely, right? So you're going to need Oracle, piece of middleware that's going to talk to both chains. It actually becomes a little bit easier. There's more provability around what the Oracle can provide in terms of what happened there and what happened here. It can reference kind of on-chain events in both places, and so provability and like faking things, that question gets mitigated pretty seriously. But once again, as much as I'd like to see supply chain data in a public blockchain or in a semi-private blockchain sometime soon, the more you work with each of these huge industries, the more you realize just things move slowly, and unless there's like a financial crisis, the adoption rate is gonna happen, but just slow. We, for example, already have some of the early things that we did. Even on our interface, you can easily have an Ethereum smart contract releasing Bitcoin. So you can basically show up and say, when this Ethereum smart contract state goes to this value, to this kind of state change, then release this Bitcoin using this multi-signature scheme or some other scheme. So we already have cross-chain kind of payments happening from Ethereum smart contracts. And it's working well. It's working well. We can show a lot of proof in both places. It's not like a ton of compatibility, but that's not the point. The point is, that's definitely something that we're going to probably switch our focus to in however many years it takes to get these systems to be the ubiquitous source of some kind of data and some kind of payments mechanism. So like if a central bank digital currency comes out tomorrow, we'd be sitting here and just knocking out some kind of Oracle to connect Ethereum to UK coin or Fed coin or whatever, in whatever way that would be possible. I can speculate on that. It's interesting, very interesting, but we'll see. What's next? Yes, finally, the one slide anybody's going to care about, the HSM SGX thing. So privacy, basically, you can have kind of privacy where you say, I have an Oracle, here's the Oracle software it uses, here's what it computed, are you okay with that? Yes, you are, okay. We're going to have an off-chain computation in an Oracle service, so an Oracle run by us, or an off-chain computation in an Oracle run by you or by me, or by all three of us, and then we'll compare results and do a multi-signature scheme. So that's kind of the lightest level of off-chain computation you can have now, which will create privacy for that computation. That computation will not be public. It will be in the hands of the Oracle provider, one or many. Right? So today you can do that. We make that relatively easy to do. So if you have a scheme where you have 2, 3, 4, 5 participants, and you're like, oh my God, we don't have a way to do this part of the smart contract because it has to be private for legal reasons. What you could do, not like the best setup ever, but one of the better ones you're going to come to today is, okay, we're going to run an Oracle network for this part of the computation, and then the rest of the computation is going to happen on-chain. So then on-chain is public or semi-private or whatever permissions of the chain are, and the off-chain computation is obviously with whoever the Oracle kind of operators are. Could be us. We do that for people, so it could be us, could be other people. It depends. The better version of this, so the better version of this that's coming sometime soon, is HSM based. So basically what's happened with the hardware security modules that came out of DRM land is let's do more complex computations on them, basically. Let's have them hold the private key and then do a more complex computation. And so now it's kind of looking like, well, it is. Intel is going to release a separate separate kind of HSM solution called SGX, where you can run code in a more trusted environment. It can be relatively complex. That trusted environment can have the private keys. There's ways to get the private keys to it that don't expose them, and that's up for debate, but you get it. Sorry, I'm just looking. I just know it's kind of. I'm just waiting for it. I know there's something in this. There's flaws in everything, for sure. With this GX, one of the common questions is how are the keys issued to the people who get the SGX instances? That's done and controlled by Intel, so that's one issue that's come up. But Intel SGX seems like the closest, probably the best thing we're going to have for HSM. And I mean, it is Intel after all. Like, there's something to be said for that, right? They've been around for a while. They seem to be okay at what they do. So maybe, right? Who knows? The two folks that we're working with and that we feel are closest to making this a reality are the folks at Cornell's IC3 initiative with something called Town Crier. And we're very glad to be working with them and seeing how we can help and try and get some kind of HSM-based smart Oracle. And then likewise, we're also working with Microsoft on their Bletchley offering, specifically in this piece of their Bletchley offering, something called Cryptlets, where it's kind of supposed to offer this feature. And so these are the two paths that we're pursuing to hopefully offer this kind of this added level of attestation to what's going on in the Oracle, along with all these other Oracle features that I've just described.
Can you give me an example of how the HSM solution would help solve this problem?
So yeah, basically what happens is, let's say you want to do a computation off-chain because there's no privacy yet, or not enough privacy on-chain. You would take that computation and, purely theoretically, we're talking here, you would either give it to an EVM running in an enclave, or you would give it to something that can compute whatever the compiled solidity was, and that would compute it. And then it would return a signed kind of answer. That signed answer would then presumably be immune to some amount of man in the middle because there's a TLS connection between the enclave and network resources, like low-level network resources.
People are supposed to be able to trust that the value that came out of the computation.
Yeah, they're supposed to be able to trust.
Code that would have run on chain.
They're supposed to be able to look at this HSM and go, if I had run that code, I would have got this value. That's what would have happened. And then it's supposed to be like, Sergey can't mess with the HSM because then things won't, add up. Yep, it's interesting. It's not out yet. We're excited about it. We're excited about helping however we can to make it happen. But it's very early days. It's definitely something we're super excited about. It's definitely something that could solve a lot of these questions that we get a lot of the time. But really, if I had to guess, I would say in the long term, on-chain privacy, computation of encrypted values is where we're going to end up in the long term. Like
Fully homomorphic encryption system.
Homomorphic, I don't know. I'm not a homomorphic encryption expert. I know there's a lot of hugely computationally intensive stuff going on there that I can't begin to understand. So I don't know. You'll still find use for this if you want to put in values. So let's say you didn't want to put in a computation. Let's say you didn't want to do an off-chain computation to solve this privacy problem, this on-chain privacy problem. Let's say you wanted to just be really assured that the value that came from Thomson Reuters was the value that, like Thomson Reuters value, without relying on their standard security practices, then this could still solve that for you. And then the real question will end up being, do you want to pay for Intel SGX enabled hosting, or does the risk reward not add up for whatever that costs? Might be everybody pays for it. It might be only some people. Who knows what it's going to cost, and we'll see, right? I'm guessing it won't be much, but I don't know. I don't know what's going to cost. I'm not in those meetings. Okay.
So can this problem also be solved by some type of validator scheme, like voting schemes?
Oh yeah, I mean
You know,
it
like
can,
stuff like
it can, but
like,
then you end up in these interesting conversations where you just have networks upon networks, and then you have questions of who's running those networks, and then you have the new questions of like, so now we have multiple networks, right? And so now we need to support these multiple networks, and then you have all kinds of like, the hell was it called? Thundering herd problem or something. And in any case, you have 20 people verifying the same API. So instead of making one API call, you're gonna do 20 API calls. So it's gonna run 20 times as much, right?
right, but if you like say if you have a stake, like and the penalty is high, then like theoretically, like and if it's really easy to prove that someone did something wrong, then theoretically you don't have to ever do the validation because it's so easy to prove something.
Yeah, that's the other problem. People can look at other people. So what could end up happening is everybody could kind of go, I know that guy over there does validation. I know he does. I know him from places. He's a guy that likes to validate things. Like he wants to do it. And then instead of them validating it themselves, they'll just look what he said. And then there's a possible solution to that, but then it ends up getting even more complex and not working in certain ways. What you're talking about is setting up what we call internally an Oracle network. Right? It's a network set up for providing the services of an Oracle in a kind of more redundant way, right? With multiple parties getting the data, verifying the data. A lot of the problem there is around incentives. Some of the problem there is around people being able to prove that they did the work. So they might not be able to prove they did the work, and you might end up in that scenario where everybody knows one guy does the work, and 100 people collapse to one guy. And then if you figure that out, what do you have to do, right? You have to mess with that one guy. And your 100-node network isn't a 100-node network, right? It's a one-node network with 99 people that copy the one guy. So that could happen. It hasn't been implemented. We've looked at it. We've tried versions of it. It has consensus problems because you can't prove that people did the work. Well, there's ways. We can talk offline. This is like a very specific. I don't know if everybody's super into the specific question. So the next steps, if this stuff is interesting, is the next step is for the computer to work. Okay. So the next step is you guys can go to github.com/Oracle Kit if you're interested in running your own Oracle. The Oracle Kit is basically a number of individual services that kind of work together to perform different functions of the Oracle. There's the main service called the Smart Oracle. Then there's something we call Way Watchers, which basically watches smart contracts and informs the Oracle about state changes. That's a separate, kind of very easy to use service that you're welcome to use. We've open sourced it. And then there's a few other features that basically support the main function of the Smart Oracle. That's if you want to run your own Oracle. If you don't want to run your own Oracle, we can host a version of the Oracle Kit. You can start using it. And then when you get to a certain size where you do want to run it yourself, you can transition from us hosting it to running it yourself. If you work at or know data providers or payments providers, and they're thinking about how to relate to the blockchain space, and they have smart engineers who are interested in this stuff, we'd be thrilled to talk to them. We'd be thrilled to say, maybe you don't need to make your own blockchain. Maybe you kind of just need to offer what you do well to smart contract developers through an Oracle, and we can get that up and running in 2 weeks using your existing APIs, which is basically what we tell them, and then what we do if they're into it. The other thing that I've mentioned once or twice is the creation of your own Oracle. So here you see some of our public Oracles that have consistently been updating themselves. In this case with the Bitcoin to USD price. This is the federal funds rate I mentioned. These are just public Oracles that we've made available to people. I can leave something in the comments later on that people can use. We're slowly making more of these, but we really make them on request. So if some people just need an Oracle and they have a data feed, and we can make a public Oracle or really, we've had people already make their own public oracles that they then share with a number of other kind of app folks that they work with. So actually, really quickly, we're going to just quickly run through what that looks like. So then you go here. This is on our site. This is that very simple process of making your own oracle in about 10, 11 minutes. You go here, you choose what type of oracle you want. Currently on the site is Ethereum and Bitcoin. So you make an Ethereum oracle or a Bitcoin oracle, or you can make one of each. You would go and create your own oracle, and you would see a screen like this. So in this case, I'm going to an API. This is the CoinMarketCap API. So let's say I cared about some coin's price to have some kind of smart contract as a derivative do something based on that price change. So then I take the API, I go here, it basically parses it, and then you can, we're at the Ethereum meetup, I'm definitely going to choose Ethereum. So we're going to look at this price. You know, we want to get that price. We want this part of the data feed to be consistently fed into our oracle. Then we say, okay, I want to make it until the end of this year, because that's how long my contract's going to run. I mean, that's one interesting thing that an Oracle service can provide. An Oracle service can provide a guarantee that, okay, I have paid you to run an Oracle for the life of my contract. So my contract will live for a year, and the data inputs will live for a year, and maybe the payment output Oracle will also live for a year and exist and be paid for to live for a year, right? And somebody is responsible for doing that. And they're responsible for making sure that as long as the contract is alive, it's getting data. If you're doing like true peer-to-peer finance, where both people don't trust each other, which makes peer-to-peer finance sound so much worse, doesn't it? And they're both just like, I don't want you to run the Oracle, I like you, but I don't want it, and the other guy's saying the same thing, then something like this is useful. Where you can go to an Oracle service provider like us and you can say, okay, run this Oracle for a year, that's how long our contract lasts, do this. And we do that. So then you can select all kinds of things like, do I want it to get pinged at 8, 11 a.m. or whenever, and you can do scheduling and all kinds of different, recurring, and there's all different ways you can tell the Oracle to do things, to get some data and then give it to your contract, and many different ways.
What's your Oracle key written in?
Huh?
What's your Oracle key written in?
The Oracle kit itself? So the Smart Oracle right now is written in Ruby, and then we're probably transitioning to Go sometime in the future, but we're going to keep API stuff consistent, or as consistent as we can. Yeah, we take that very seriously. We obsess about that a little bit too much, I think, but yeah. Okay, long story short, you give it a name, you give it a description. This is just so that people that show up can understand what it's about. You go to attachments, you can attach legal documents. So oracles can be a way for people to e-sign on a legal document. Or an oracle can act as like an interface, a web interface for people to do e-signature. So let's say I wanted somebody to have an interface to e-sign for a contract to move to a subsequent stage, right? I need Joe, and I need to make sure that I meet e-signature standards to make sure that Joe is the one e-signing to go from state 1 to state 2, right? Well, then you would have a page like this, but there would be a button, and only Joe could log in and identify himself to whatever degree of e-signature you deem necessary, and then sign off on basically another contract, which would then ping your contract, which would be written in a way that reacts to the oracle. So oracles can basically be an e-signature solution. But we actually don't even want to do that. What we really want to do, we want to get good e-signature solutions to run their own oracle. Like, once again, it just makes sense, right? So cool. So here I am. I've previewed it. You can add other signers. This is that e-signature thing. So we have a thing where you can add other people by email to sign off on your oracle. If you wanted everybody to agree and say this oracle is the oracle we're going to use for our smart contract. This is one again that like I really don't trust you peer-to-peer finance thing, which has not gotten as much traction as you would think. But yeah, most of the traction on oracles for us has been around basically people making applications. People making applications that need an oracle to do something, whether they're POCs or like their own fintech app, or data providers, payments providers. So our oracles have privacy. There's some amount of privacy. So this oracle is public and anybody can access this URL. If you select this, then only designated people will be able to access the URL. We have a signature deadline by when people need to sign for the oracle to become valid. And then you finalize the oracle, and then it, oh my God. Okay, I don't know if I'm going to do this. Can I do it? Can I do it? Can I do it? I didn't do it. Okay, sorry. That might not be as much fun for you as it was for me. Much longer. Okay, long story short. So now we've signed it. If we had other signers, more people would sign it. And now we can send Ethereum to it. Sorry, we can send Ether to it. Sorry. We can send Ether to it. And so it requires a certain amount of prepayment. It says prepay me to run for the period you required for me to exist. You pay it, and after you pay it, it generates a page like this with all kinds of details, with something called the JSON schema. So another interesting thing that we have for our Oracle kit, which is open source under MIT, so once again, no worries there, is JSON schema. So if you wanted to manage like thousands of oracles, you would have a way to do it in JSON. You would have a way to do it in a machine-readable format, so it would be relatively scalable. And even our oracles that are generated on the site use this JSON schema, and we're actually working towards getting other people to use it. And that's like a whole other thing where we think it makes sense for there to be a standard that developers can show up and they can look at an oracle and it can be like, okay, what is this oracle about? And they see a JSON schema that describes what the oracle is about, instead of seeing like however many different variations of oracles there ends up being, right? Like that just seems to make sense. So we have a JSON schema that we use, that we open source, that we encourage other people to use, so that if the other benefit of that, just as a little aside, is what I've seen, and it makes sense, is that when people go to evaluate a contract, a smart contract, they're like, okay, so what's actually going on here end to end? And the end-to-end includes the oracles, right? It includes the triggers, and it includes like the off-ramp for what the smart contract is going to end up doing. So at that point, they start looking at what is the oracle, what oracle do you use, why do I know it's a good oracle, who runs it, all these questions start coming up. And so if we get to a place in however many years where people can read contracts in a relatively standardized way, right? Like they can read the smart contract code, and it's relatively understandable to almost everybody. Then what we would also probably want is for people to show up and to be able to really quickly read what the oracle is about, right? We would want them to be able to go, here's what the oracle is about, here's what the contract is about, here's what the other oracle is about to pay. Okay, I'm good, I know what everything's about, I can move on to my next contract. That's really what the JSON schema, it's like one of those more long-term.
So can you view the source of an oracle? Can you actually view the source of an oracle?
What do you mean the source?
So like the source of the Oracle code, like the actual app, Oracle app.
Oh, so
are we only ever consuming it like an API?
Yeah, that's the difference. We have these two kind of opposing views at the same time. So we say, here's an Oracle service, because people have limited time and they want to do things quick. And then we have the open source Oracle kit. So that's source code, and that's open.
Or you're not running that on your service. So I thought you would take
running
modify that, and then you'd run that. Okay, so that is the code that is that.
Yeah.
But if I wanted to build my own, I would take the
Oracle kit.
Your Oracle kit and modify it.
You can modify, you can do whatever you'd like.
But just a user of Ethereum cannot look at the source of a
No, not of our web app. No.
not even the web app, but the actual the logic of the
backend.
Oracle. Yeah.
Well, no, they can look at the,
Because that's part of the end-to-end, right? Like, you want to verify that contract, don't you want to verify the code is correct in your Oracle?
that's what I'm saying. So the version of that we have is a JSON schema that's generated by each Oracle that in an understandable, quick format says what it's doing.
Okay. So that's like the equivalent of the source. It's like
It's a representation.
it's a transform.
It's a
of the source or
JSON
something.
representation using a schema that we've come up with from our experience, that we've open sourced, that we encourage other people to possibly adopt if they like it, which we're going to keep using, which in however many years will possibly, maybe, solve this problem, right? So that you don't have to go there and read Oracle code written in whatever language you don't know. You can just go, oh, they use the standard JSON schema description of oracles. What does that say? That says this does X, Y, and Z. You know, however many hours saved, you're on to your next. Does that make sense? Yeah, this is one of those like kind of public good in the future, way in the future things. This is for those types of people that are interested in that kind of stuff.
Could one build a clone of an Oracle from the JSON schema?
So you can do
That would be tough. You would, we don't have anything for that. It kind of just goes one way. You just generate the JSON schema most of the time. Or all of the time.
Question, what,
Yeah.
all right, if you have generating data, do you have to pay some ether, let's say after, to preserve historical data? If you preserve it on-chain or you sort of direct it off the chain somewhere? And can you come back a year later and say, oh, I wanted history to keep going. I don't want it to get wiped out. How does that work?
So you would make an oracle, and for the operations that you want it to execute, you would pretty much prepay, or you would give the oracle enough money to do that operation. In this scenario, you're prepaying it for it to put in data from this API on a daily basis at a specific time. So that's the operation you're prepaying for with like
on the chain, on the blockchain, was where the data lives.
Yeah, you're paying ether to the oracle that it's going to then use to pay the fees to perform the operations of inputting the data. Yeah.
But if you want, you have to do something else to read it to save it off the chain somewhere. If one wanted to do that.
That really depends what you want to do. Depends on the complexity. You could look at it through an explorer, or you can have an oracle take it. We have something called Way Watchers, which is also in the Oracle kit. So what Way Watchers does is it watches the logs. It watches the state changes of a contract, and then it can send that information, in our case, to the Smart Oracle. In your case, to wherever you want to send it to. It basically generates an API that monitors a contract. That's just a separate part of the Oracle kit, and we built it that way because we like service-oriented architecture. Basically, we don't want to build like a big jumble thing. So, in your case, you could just go use Way Watchers and not use the Smart Oracle. I mean, you could do that if that's all you wanted, what you just said. Yeah, feel free to message us on support.
Okay.
Support at Smart Contract. You know, we have limited time, but we're excited to help people get a real use case somewhere and like get it working. You know, that stuff turns us on. We're into that.
Have you looked into like building a reputation around an oracle?
Yeah, sure.
Or identity, like how do I know that I can trust the source?
Mm-hmm. Yeah, that's something that's definitely going to exist, but that's in the future.
Okay.
That's one of those future problems that's on the roadmap, but I think that's something we're going to look at solving when it becomes a requirement for a developer. Right now, the requirement for the developer is, I don't want to build an oracle. And then after that, if they figure out how to do that, or if they use us, or if they do whatever else, then it's like, I don't want it to pay in coin stuff. I want it to pay, and
I think
it's a priority thing, basically.
If you start issuing and you sign, like you run an oracle, you sign something with a key, and say, how do I know that you are the right person to sign it? And this hasn't been compromised. Or if you lose the key and then you change your like private key into another, how do I know that it's the same provider?
So basically what happens is you usually you almost always generate the oracle first, and then you generate the contract that references the oracle. You're talking about a scenario
I'm
where
more like a developer perspective. Like someone runs oracles, and I want my users to trust that the oracles I'm referring to make sense, and that they can trust the sources. Like
what do you mean by make sense?
So say if people on a website like make a prediction market platform, where you can say like, okay, you can have a source for whatever Ether price data. How do they know and understand that the source which is used for making like the prediction outcome be reliable? How do they know that they can trust whatever your oracles or 100 people's other oracles?
I got it. So there's two answers to your question.
Okay.
The first, simplest answer to your question is if you go on and you do the quick path to make an oracle, for example, on an interface, right here we have the API link that you're using. It's also in the JSON description. You can click on it. You can look at the HTTPS certificate. So the link, the data source, the URL that's being used for the oracle is provided here and in the JSON. The other answer to your question is the HSM-based approach that I mentioned. So that's really going to be where it's not going to do computation. It's going to take data, sign it within the HSM, and then pass it on into the chain.
You can take it off that.
How do you deal with key compromise? So, just I'm not an Ethereum expert on this, so please bear with me on this. But so if a Oracle private key is lost, are all smart contracts that depend on that invalid?
Are all the smart
Can I
contracts?
replace the public key inside a contract with the new updated private key?
You know, the way to really handle that we've seen put into practice more than anything else is you create some kind of clause to either revise or review certain parts of the contract, because the immutability of these chains is important, but those clauses are also worrisome from a security perspective, and they have like the ability to revise a contract through its own code is like, for obvious reasons, a worrisome security vector. So the thing that I would say is that that's not a super solved problem, but there are ways to mitigate it if you're very careful. Yeah, smart contract security is definitely getting better, but really the thesis still right now seems to be simplicity.
So you're dealing with like fake data feeds. I know that there's a cryptocurrency called BitShares that has a delegate model, where if one of the feeds starts returning fake data, enough of the network would vote against that node. And again, it doesn't necessarily apply in this scenario, but it's another way of dealing with that. It's
Yeah,
like
you're right.
voting in a reputation system.
And the fellow back there mentioned that, and that really gets into these whole questions of incentives for consensus. And a lot of the times, incentives for consensus end up after long conversations, long ones, with a lot of whiteboard markers, end up resulting in the question of how do people prove they did something. And if the fallback is like a bunch of other people vote against them, then you start getting like these layers upon layers of incentives. And then you start getting into questions of, will those incentives work? And then the answer is like, there's no field of sociology or psychological statistical analysis or economic statistical analysis which will tell you that these three layers of incentives that you came up with, giving people digital tokens or taking them away, will work. And at that point, you're basically left with a condition of, okay, time for me to go wherever and start making it happen and hoping for the best, which is not always something people want to sync, not sync, but use. How you get it, there's a risk on solving it that way. The more you think about it, basically, the more the cumulative risk starts to go in a direction that it doesn't, there's too many things going on. Does that make sense? I mean, that's more or less it for me. You folks can feel free to reach out to us at support@smartcontract.com. We're excited to work with you on your use cases. We're excited to simplify this problem for you. We want to help. We want to see the space succeed. That's why we're building a lot of this. So please feel free to let us know how we can help on this point.
just a reminder, next week we have another event at Cardozo Law School, their Tech Talk. It's more on like the legal issues of smart contracts. And then either the following week or the next week after that, I'm working with the team from Matchpool, which is a blockchain Tinder, I don't know, some sort of relation.
It's good, sir. Match.com, blockchain.
So that's gonna be either the following week or the next week after that. Also.
You can see how much the other person's how much cryptocurrency they have. They can prove to you how rich they are, right up front.
That's good. That's important.
Well, thank you. Thanks again to Thoughtworks.
Okay.